Hello everyone. In this session we will see some of the applications of physics. Since the name of the series is application oriented physics, I will tell you some of the applications. I have taken out 3 applications which the people who don't know physics, not very much acquainted with the concepts of physics, they might call these applications as magics. So the first application is mirage, the second is banana kick or swing, and the third application is echo. So let me one by one explain these applications. I'll tell you the basic principles on these applications work, and they are not magics. So the first is mirage. Mirage is what you see in desert places, or even when you go for long journeys, when the road is hot, you feel as if there is water at some distance. So that is called mirage. In desert places also, you get that feeling that there is water around, and you just run towards that water, and suddenly it vanishes. So people feel as if it's a magic in the desert, but it's not a magic. As you can see, this is an object in the desert. It's a tree. Probably there is a stone as well. And this is that hot sand in the desert. You are this person. You're walking and you reach this tree. You're a few hundred meters from the tree. The sun is directly overhead. And what happens is the rays of sun that reflect from the tree, they start traveling. You know the laws of reflection, angle of incidence is equal to angle of reflection. We'll cover all these basic concepts in the actual lecture series, but I'll just tell you how physics can explain so many magical effects. So when this rays of light, they get reflected from the tree, they start traveling downward towards the sand. But since the sand is hot, the air that is very much near to the sand is relatively very rare. Whereas the air which is a bit away from the sand, so if I call this air as rarest, this air is relatively dense, so I'll call it rare. The air above it is dense, and the air above that is even more denser. And these rays of and these layers of air are arranged over each other so that the density of the air increases as you move away from the sand. So the property of light is that when it is incident on the boundary of a denser and dense layer, the property of light is it always bends, it always bends away from the normal. And this phenomena continues, it keeps bending away from the normal. Then there is some phenomena called as total internal reflection, which we'll see in our actual lecture series. So because of that, the ray of light gets reflected and it enters into the eyes of this person. That is in your eyes. Your eyes are linked with your brain, and they have this property that they try to trace back from where does this ray of light originate, and they trace it back to ground. So whatever rays of sun are reaching here, all of them bend like this and go into your eyes. All of them bend like this and go into your eyes. Your eyes, which are linked to your brain, they trace it back to the tree, and you feel as if the reflection of tree is inside the land. So what's this? It's the sign of water, right? If there is a reflection inside the land, that means it's the sign of water. So you feel as if there is water here, and you start running towards it because you are already thirsty. You are in the desert, you start running towards it, and it vanishes because the effect is lost as soon as you reach the tree. This first effect. The details of the effect, how and why those rays of light bend towards or bend away from the normal and all, we'll see when we look into the chapter called light. Now the second effect is banana kick or swing. So if you are a cricket or football fan, in cricket the bowler makes a swing, and in football there is something called as banana kick. So the effect that governs both these applications is the same. This is the ball. When a football player, he kicks this ball, he kicks it at a corner, either the right corner or the left corner. So from the experience, they know which corner to kick so that the ball will turn either rightward or leftward. So when they kick at one corner, the ball starts rotating about its vertical axis. It starts rotating, as well as since he has kicked it with a large force, it starts moving forward. So the ball is moving forward as well as it is rotating about its axis. The air around the ball it also starts rotating. Now the air rotates because of the motion of the ball. It has two components of motion. One is rotation and one is forward motion. These two components of the motion adjust in such a way that on one side the air, its pressure is more, and on the other side the pressure of the air is less. How does it happen? What is the linkage between the motion of the ball and the pressure of the air? That all will be explained in the chapter called fluid mechanics. So it has something to do with Bernoulli's principle, but we'll see when we look into that chapter. So pressure here reduces, pressure here is more. That is why there is net leftward force on the ball, and when it is moving ahead, it will swing to left side. That is typically called as banana kick. And in swing also similar effect is observed. You might have seen that ballers, they try to roughen the ball on one side, they apply their saliva or they rub it against their clothes. So that all increases the swing effect. The third effect is echo. When you visit area which has hills, mountains, you observe this effect. Or even if you are inside a huge hall which is lengthwise very large, say more than 20 meters or so, you observe this effect of echo. So echo is simply that if you call out physics in mountains, it will call back physics, physics, physics. You might have observed this effect. So that echo effect, you reach the area that has mountains, right? And you call out your own name, or you call out the name of the subject that you like the most, physics. When you call that, the sound originates from your mouth, it strikes these hills or whatever obstacles are there, and then it comes back, it gets reflected and it comes back.
Oh my god, that's sick.
Can we clap? I bet that will work.
No, wait, up you men.
Now with what speed does this sound go? How does it reflect back? Why am I representing sound like it's in the form of layers? Why am I doing that? All this will be answered when I cover the chapter waves, and especially when I cover sound in that chapter. So sound goes with some specific speed and it comes back with some specific speed, the same speed. The speed of sound typically is given as 340 meters per second, but it depends on so many other conditions as well. So we'll cover that when we cover chapter sound. It goes and then it comes back. Now human ear, this is human ear. It has a property that it can distinguish between two sounds that are received by 1/10 of a second, that are received by a difference of 1/10 of a second. So when you shout out physics, that is when your ears hear first sound physics, and then it gets reflected back and comes back to your ears. That's the second sound that you hear. So you hear back physics. If the difference between first sound that is directly heard from your mouth to ears and the second sound that is reflected by the hills to your ears, if the difference is more than 1/10 of a second, then you hear something called as echo, because you can distinguish between those two sounds. And for that, when we'll do the elaborate calculations, you will find that for that the minimum distance needed is 17 meters between the source of the sound and the obstacle. So the distance between source of sound and obstacle must be more than or at least equal to 17 meters. Then only the effect of this echo is observed. Again, I'll repeat, all these three concepts will be in detail seen when we actually go for the application oriented physics series. Thank you.